Dear students, welcome back to the competitive classes with respect to the equilibrium. So in the previous various sessions I have discussed some of the synopsis, means what are the various basic terms, what are the various formulas, and what are the various shortcuts, or it will be the tricks that has to apply in solving the multiple choice questions related to this particular chapter. So here the main thing with respect to this chapter is, as if we are calculating either the pH or the pOH or the pK or pKw or H plus, whatever it may be, we need the concept of log and then log and as well as the anti-log. So here you have to be very familiar first with respect to that. Log 1 to 10 you have to be very familiar. Log 1, 2, 3, 4, 5, 6, 7, 8, 9 and then 10. Log 1 is 0 and log 10 is actually 1. So here it is remembered as 0.3, log 4 is going to be 0.6 and log 8 is going to be 0.9, okay, because it is 2 square and then 2 to the power of 3, that is 0.3, 0.6 and then 0.95. So now it is 0.4771, it is remembered as nearly 0.48. So here it is going to be 0.6991 nearly equal to 0.6991 is nearly equal to 0.7. So here it is going to be 0.78 something, here it is going to be 0.85 something, here it is going to be 0.95. So this is how we are going to remember the values of log. If we know the log, means the reciprocate of that one is going to be the what? The anti-log for that. Okay. So for that you have to be very familiar with respect to the concept of log. Okay. Let's start the multiple choice questions in solving. The first one. The equilibrium constant, what is that? K for 2Hi gives rise to H2 plus I2 at the room temperature is going to be 2.85, and that at 298 Kelvin it is going to be the 1.4 10 to the power of minus 2. Therefore, what that it implies? So here Kc directly proportional to T means the forward reaction is endothermic. If products by endothermic means reactants are more stable compared to that of the products. That you have to be very familiar. Suppose if Kc is inversely proportional to temperature, the forward reaction is going to be the exothermic, where the products are more stable compared to that of which one? The reactants. So now 2Hi gives rise to what plus what? H2 plus I2. It is one reaction. So we have to decide whether it is exothermic or endothermic. At T 298, because it is room temperature and T1 is 698. Here the value of Kc is going to be 2.85. Here the value of Kc is going to be 1.4 into 10 to the power of minus 2. As temperature increases, the value of Kc, what happens here? Decreases. Means Kc is right now it is inversely proportional. If it is inversely proportional, the value of this one is going to be negative, means it is an example for a what thermic? Exothermic. According to the exothermic means the products are what stable? More stable compared to that of the reactants. Means Hi is not resonance stabilized because it doesn't have a what system? Conjugated pi system. Hi is an exothermic compound. No. Hi is an endothermic compound because it is a backward reaction. Then Hi is stable, or H2 and Hi is stable at room temperature. Hi is less stable because the reactant is going to be the more stable if the forward reaction is reactant is going to be the less stable if the forward reaction is what thermic in nature? Exothermic. Okay. The pH of what's that? A solution obtained by mixing what and what? 50 ml of 1 normal HCl with 30 ml of 1 normal Na, which is how much? Given the log value is 2.5 is 0.3979. No doubt it is an acid base reaction, but 100% neutralization depends upon whether it is having the number of gram equivalents of an acid must be equal to number of gram equivalents of a base. Therefore, on that basis we are having the 4 different types of salts, that is strong strong, strong weak, weak strong and then weak weak. Based on that relative strength we can decide whether it is acidic or a basic or it may be the neutral. Strictly we can't say that it is equal to the neutral nature. Let's have the first 50 ml of 1 normal HCl and 50 ml of 50 ml, another one is 30 ml of 1 normal NaOH. So here, in both the cases, the concentration is same, 1 normal, no doubt. But this is in excess compared to this. Means I can have more amount of which one? HCl. HCl, or indirectly it is called as H plus, left for 80 cm3. How I am getting 80 cm3? Because it is the 50 ml of HCl and then 80 ml. Total 30 ml of NaOH. Total it becomes what? 80 ml. We know that it is NV of by 1000 of HCl minus NV by 1000 of which one? NaOH. Because we are having more minus less. Which is the more here? HCl is more. 50 into 1 divided by 1000 minus 30 into 1 divided by 1000. That's equal to 20 by 1000. 20 by 1000 is actually 1 by 50, I think. 1 by 50. What is that? It is the HCl that has been left for how much? 80 cm3. Therefore, what is H plus concentration for 1 dm3? 1 dm3 means how much? 1000 cm3. That's equal to 1000 into 150. 1 by 50 divided by 80. 1s are 20s are 20 by 8 is actually 1 by 4. 1 by 4 is equal to 0.25. That is of the form 10 to the power of minus 1. What is H plus concentration here? It is 2.5 into 10 to the power of minus 1. Therefore, what is pH? pH is actually the negative log of what? H plus. Negative log of, what is H plus here? 2.5 into 10 to the power of minus 1. We know that it is of the form x into 10 to the power of minus n. Then pH is directly given by what? X. What is x here? 1 minus log of 2.5. That is equal to 1 minus 0.2.5 log is 0.3979. That is equal to 0.6021. So therefore, the answer with respect to that one is going to be 0.6021. Okay. First, we have to decide what type of salt it is. Sorry, whether it is an acidic or a basic or it may be the neutral. As it is not having the equal volume and then the equal concentration. No doubt the concentration is equal, but the volume is going to be the different. On that basis, we can decide that the amount of HCl is going to be more. Therefore, we are having more of H plus indirectly in the form of HCl for the total of 50 plus that is equal to 80. Then, with respect to how much? 1000 cm3 we have to calculate, so that the concentration for H plus is going to be 2.5 into 10 to the power of minus 1. Then substituting the value of H plus to get the value of which one? pH. Okay. Let's have the third one. A gaseous phase reaction is allowed. Gaseous phase reaction is allowed to attain an equilibrium as A gives rise to what plus what? B plus C at a constant pressure of P. The partial pressure of A at equilibrium is found to be the P by 2. Then the value of equilibrium constant Kp is what? So here it is first an example for a gas phase reaction. A gives rise to what plus what? B plus C. So here Pt is equal to Pa plus Pb plus Pc. Why? Because according to the what? Dalton's law of partial pressure, the total pressure is always equal to the sum of the what pressures? Partial pressures of the individual gases. Therefore, here the total pressure is given as P. Pa is found to be P by 2 plus Pb plus Pc. But this total can I say that is equal to P by 2. Why? Because the total pressure is P, means the partial pressure of A is P by 2, means these two must compulsory be what? Therefore, also B and C are in the ratio of what is to what? 1 is to 1. Means these two sum must be P by 2, means individually it is P by 4 I think, and this is also what? P by 4, because they are in the ratio of what is to what? 1 is to 1. Then apply the value of KPR, the formula for it is PB divided by, PB PC divided by PA. What is PB here? P by 4. What is PC? That is also P by 4 divided by P by 2. 1s are 2s are. That is equal to P by 8. What P by 8? It is the equilibrium constant for the gaseous phase reaction of the type A gives rise to what plus what? B plus C. Okay. Next, which among the following is the what acid? Strongest acid. How to decide whether the acid is found to be the strong or it may be the weak? So here, that we already discussed in the concept called as halogens. A central atom having the highest oxidation state will have the what nature? Acidic nature. So here, first one is HClO3 I think, the second one is HClO4, the third one is HClO2 and then HClO. No doubt it is an acid means it is plus. Oxygen is minus 2. Therefore, this is found to be the plus 1, this is found to be the plus 3, here it is found to be the plus 5, here it is found to be the plus 5. Sorry, this is found to be the plus 7. Hypochlorous acid, chlorous acid, chloric acid and then perchloric acid, which is having the highest oxidation state, it is found to be the B, that is found to be the perchloric acid. Okay, that is higher the oxidation state of the key atom or the central atom, higher is the what strength? Acidic strength. Now, the weakest base among the following is found to be, what's the weakest base among that following? How to decide? The base is found to be the weak. So here, weaker the base is equivalent to conjugate acid is strong. Among the conjugate acid and a base pair, if one of this one is found to be the weak, then the opposite or the conjugate is found to be the strong, or it may be the vice versa. For example, H minus, CS3 minus, CS3O minus and Cl minus. What these are? They are the conjugate, they are the bases. How they get converted to conjugate acids? By addition it becomes H2, here it becomes CH4, here it becomes methyl alcohol and here it becomes HCl. So all these are acids and all these are what? Bases. So as if we know that they are almost neutral, it is not found to be that much acidic. This also almost not acidic because the alkoxide ion is not stabilized by the resonance. Therefore, this is found to be the what acid? Strong acid. If this be the case, its conjugate is found to be the weak base. Therefore, the weakest base among that one is found to be the conjugate acid, that is found to be the HCl is found to be the strongest, means Cl minus is the weakest base. Okay. A saturated solution of which one? Silver sulfate is found to be 2.5 10 to the power of minus 2 in terms of molar. Therefore, what is the value of solubility product with respect to that? Saturated solution is implying it is called as solubility. It is called as what? Solubility. That is called as S is given. Means the solubility always refers to the what solution only? Saturated solution. Ag2SO4 is called as silver sulfate because silver is what valent? Monovalent, and sulfate is what valent? Bivalent. Means this is of the type A2B type. If A2B type means KSP is equal to what? 4SQ, because we have to remember the formula. What is that? For AMBN type of electrolyte, the KSP is equal to m to the power of m into n to the power of n into s to the power of m plus n. So here, based on that, I will get the KSP is equal to what s cube? 4s cube. That is equal to 4 into s is solubility 2.5 10 to the power of minus 2 in terms of whole cube. So first I will make this as 10 to the power of minus 6. This can be written as 2.5 into 2.5 into 2.5. So first 4 into 2.5 refers to what? 10. Then what is 2.5 into 2.5? It is 625. 625 means 6.25. On simplification, it becomes 62.5 into 10 to the power of. Therefore, the option is with respect to this is A. Means first you have to know the formula for silver for sulfate, which is having Ag2SO4, which is of the type what? AB2 or A2B here. KSP is directly given by what s cube? 4s cube. Okay. The equilibrium constant for that particular reaction, what is that? N2 plus O2 gives rise to 2NO at a temperature T is given by 4 10 to the power of minus 4. The value of Kc for the reaction NO gives rise to half N2 plus half O2 at the same temperature is how much? So here, in case of reversible reaction, first, in case of what reaction? Reversible reaction. If reaction is reversed with same number of moles, let's say that, then Kc for the backward reaction is equal to 1 upon Kc for the what reaction? Forward reaction. When it is, if the reaction is exactly reversed without the change in the number of moles. Suppose if the reaction is reversed with number of moles has changed, N has changed. If that be the case, Kc for the backward reaction is equal to 1 upon Kc for the forward reaction to the power of n. Maybe a whole number or it may be the fraction. I don't know about that. Means if it double, get triple means it is a whole number. If it gets halved or 1/3 of that means it is a fraction. Suppose if the reaction is not reversed but number of moles has changed means then Kc dash is given by Kc to the power of n. When it is, if the reaction is not reversed but the number of moles has changed means the equilibrium new constant is given by Kc dash is equal to Kc to the power of what? N. Compare these two. N2 plus O2 gives rise to 2NO means it is converted as NO gives rise to half N2 plus half O2 means the reaction is what? Reversed. Reaction is reversed. But the number of moles is N2 here it is half, O2 here it is half, 2NO means here it is 1NO means number of moles gets decreased or changed. Therefore, Kc for that backward reaction is equal to, in this case N is equal to half here. Why? Because it gets decreased by how many times? 2 times. 1 upon Kc for the forward reaction to the power of n. What's the Kc here? It is 4 into 10 to the power of minus 4 to the power of 1 by 2. That is equal to root of this one is 1 by 2 into 10 to the power of minus 2. That is equal to 100 by 2. That is equal to 50. What 50 is? It is the equilibrium constant for the reaction which is reversed and then the number of moles has been reduced to how much? 2 times or it gets halved. Okay. The equilibrium constant for that particular reaction, what is that? 2x plus y gives rise to 2z is found to be the 2.25. What would be the concentration of y at the equilibrium with 2 moles of x and then 3 moles of z taken in 1 liter vessel? So here 2x plus y gives rise to what? 2z is one reaction. So here Kc is equal to product divided by reactant, z square divided by x square into y. But here I need the concentration of which one? Y. Y is equal to what? Z square divided by Kc into x square. What is Z here first? Z is 3 mole in 1 liter means 3 square divided by, what's the equilibrium constant? It is going to be 2.25 into, what is x here? 2 mole of x. 2 mole of x means 2 square. This is 9, this is 4. 4 into 2.5 that is equal to 1. So that is the concentration of y in the equilibrium which is having an equilibrium constant of how much? 2.25. Okay. For the hypothetical reaction, what is that? 4a plus 5b gives rise to 4x plus y. The equilibrium constant Kc for that one is, first you have to be very familiar with that. Unit of Kc is given by concentration to the power of delta Ng and unit of Kp is given by any pressure unit to the power of delta Ng. So as it is a Kc here, the concentration is found to be what? Mole per liter according to that. What's the value of delta Ng for that reaction? Delta Ng is products minus reactants. What is product here? 4 plus 6 minus 4 plus 5. That is equal to 1. That is equal to 1. Therefore, it is mole per liter. Mole per liter is nothing but what here? D. For a hypothetical reaction, 4a plus 5b gives rise to 4x plus 6y. The equilibrium constant has that unit of what? Delta Ng is equal to 1. Therefore, it is equal to mole per which one? Liter. Okay. When a bottle of cold drink is opened, the gas comes out with a fizzle. Due to the what? It's indirectly the application of Henry's law. Okay. So here, as if we know that gas doesn't easily get dissolved in the liquid solvent. Only by applying the pressure, what happens? The excess of the solute in the form of gas gets dissolved in the liquid solvent. Usually the soft drinks, the carbonated soft drinks, we are compressing the carbon dioxide. The carbon dioxide has been compressed such that more of the what is dissolved? Carbon dioxide is dissolved. Suppose if that bottle gets opened, what happens? The gas comes out. If the gas comes out means the carbon dioxide concentration inside that one. It is not the concentration actually, it is the pressure right now. Okay, that is the pressure of the carbon dioxide inside that particular bottle goes on decreasing. Means It is a decrease in the pressure suddenly, which results in the decrease in the solubility of which gas in which? The carbon dioxide present in the water. Therefore, the option with respect to that one is going to be the A. Okay. Consider the reversible reaction. What's that? HCN gives rise to H plus plus what? Cn minus. At equilibrium, the addition of Cn minus would what? HCN gives rise to what plus what? H plus plus Cn minus is one reversible reaction. Here we are adding the what? Cn minus. Addition of what? Cn minus. Cn minus is actually the product. We know that according to what Cp? LCP. Addition of product increases the concentration of the reactant, decreases the concentration of product, shifting the equilibrium towards the what? Left. So here Cn minus and addition means what happens? The HCl concentration goes on increasing and these two concentration goes on decreasing. Preferably the H plus concentration goes on decreasing, because according to the concept of what principle? Le-Chatelier's principle. Means addition of what minus? Cn minus shifts the equilibrium towards what side? Left side, such that the reactant concentration, that is HCN concentration, goes on increasing, or the H plus concentration goes on decreasing. So here it is. Decrease the what concentration? Hydrogen and concentration, that is B. Okay. What is the pH of 1 molar sodium acetate solution? Given K for acetic acid is going to be the 1.8 into 10 to the power of minus 5. First you have to know what type of salt it is. CH3COONA, as it is a salt, means it gives rise to what plus what? Acid and then the base. What is that here? So here it is a salt of weak acid and then strong base, because all carboxylic acids are weak. Now, for that pH is given by what? 7 plus half of pKa plus log C. This is an expression for calculating the what? pH of a salt containing a mixture of which and which? The weak acid and then the strong base. So here it is 7 plus half of. First you have to know the value of pKa. pKa is actually the negative log of what? Ka. That is equal to negative log of, what is Ka here? It's 1.8 into 10 to the power of minus 5. That is equal to, according to the direct formation, 5 minus log of 1.8. That is equal to 5 minus. We don't know the value of log 1.8. Log 1 is, we know that 0. Log 2 is 0.3. 1 to 2 means with respect to 0.1 difference, it is 10 times. It means for each of these, the difference is 0.03. 0.03 into 8 times, it is 1.8, means it is 0.24. What is 0.24? It is a log of how much? 1.28. Therefore, it is equal to 4.76. What 4.76? It is the pK value. 4.76 plus log of concentration is how much? 1 molar. Log 1 is what? 0. That is equal to 7 plus 2.38. That is equal to 9 point, how much? 38. 9.38 and nearest is going to be the what? 9.4. You don't know the direct formula for the pH calculation. What is that? pH is equal to 7 plus half of pKa plus log based on of concentration of that. Means first you have to know the value of this one. That is how to calculate the pKa. pKa is equal to negative log of which one? Ka. Okay. In that equilibrium, what is that? In the equilibrium, 2SO2 plus O2 gives rise to 2SO3. The partial pressure of SO2, O2 and SO3 are respectively what and what? 0.662, 0.101 and 0.331 atmosphere respectively. What should be the partial pressure of oxygen so that the equilibrium concentration of SO2 and also SO3 are going to be the what? Equal. So here the reaction is first 2SO2 plus O2 gives rise to what? 2SO3 is one gaseous reaction. According to that, it is Kp is equal to partial pressure of SO3, they are given the partial pressure SO3 into partial pressure of O2, partial pressure of SO3 divided by partial pressure of SO2 into partial pressure of O2. Okay. So here SO3 concentration or pressure is going to be 0.331 whole square divided by 0.662 whole square into what is the value of partial pressure of oxygen? It is 0.101. Okay. So I think it is twice of that, it is again half of that. 1 za, 2 za, 2 za, it becomes 2 into 2. 1 by 4, 4 into means 1 by 0.4 into 0.1 is approximately 1 by 0.4, that is equal to 2.5. What is 2.5? It is Kp. So here if P of SO2 is equal to P of SO3 means according to this, then can I say that O2 is equal to our partial pressure of which one? Partial pressure of oxygen is reciprocal of Kp. If these two are equal means they get cancelled. Therefore, P of oxygen is equal to reciprocate of that Kp, that is equal to 1 by 2.5. 1 by 2.5 is actually the 0.4. Okay. First we are going to calculate the value of which one? Kp. Then given condition is partial pressure of sulfur trioxide is equal to partial pressure of sulfur trioxide. On that basis, P of oxygen is always equal to reciprocate of the equilibrium constant. Okay. Next we will move on to the 14th, that is the dissociation equilibrium for the gas AB2 can be represented according to as 2AB2 gives rise to 2AB plus B2. The degree of dissociation is found to be the X and is small as compared to that of which one? 1. The expression relating the degree of dissociation X with respect to the equilibrium constant Kp and then the total pressure is how much? So here the equation is 2AB2 gives rise to what plus what? 2AB plus B2. Okay. Let us take initially we are having 1, here it is 0 and 0 initially. What is the degree of dissociation here? Let us found to be what? X. If this is X and this is X by 2. Why? Because they are in the ratio of 2 is to 2 is to 1. Therefore the left is at equilibrium. 1 minus X, X and then X by 2. What is total number of moles? 1 minus X plus X by 2, that is equal to 1 plus X by 2. So here the condition is 1 minus X, assume that it is nearly equal to 1 and 1 plus X by 2 is also equal to 1. That is the condition. Okay. Now what's the value of Kp here? Kp is equal to partial pressure of AB whole square divided by partial pressure of B2 divided by partial pressure of AB2 whole square. This is the expression for which one? Kp. Products divided by reactants. First you have to know that partial pressure is equal to the mole fraction into what pressure? Total pressure. That is the formula first you have to remember. How to calculate mole fraction? It is the number of moles of that particular substance divided by number of total into what pressure? Total pressure. This formula you have to be very familiar first. Okay. Let's have it. How to calculate the mole fraction of AB here? Mole fraction is AB is X divided by total number of moles is 1 plus X. 1 plus X is nothing but what? 1, nearly equal to 1 into P whole square into. What is B2 right now? It is X by 2 divided by total number of moles is 1 into P to the power of 1 divided by, here it is 1 minus X. 1 minus X is nearly equal to what? 1. Therefore it is 1 divided by 1 minus X divided by 1 divided by number of moles of that substance is 1 minus X. 1 minus X is nearly equal to what? 1 divided by total is also 1 into pressure is what? Whole square of that. So on simplification what I will get here? X square divided by whole square is actually it is what happens when I simplify that here? It becomes PQ, we have to get only the P I think. So P square P 1 minus X divided by 1 minus X is nearly equal to 1 divided by total number of moles is 1 plus X, that is also 1 into total pressure is what? P to the power of what? 2. So that is a total mole fraction whole square. Okay. So on simplification, I am getting that, or on simplification, we will get the final answer in the form of Kp is equal to x cube, p square cancels here. Now I left with only the x cube, I think, x cube divided by x cube p along with 2 also. X cube p divided by what? 2 also, r. With respect to this one, they are given in the form of p is equal to, I think, or x is equal to, x cube is equal to 2kp divided by p. 2kp divided by p, or x is equal to 2kp by to the power of cube root of that. That is, x is given by 2kp divided by p to the power of 1 by 3. Okay. Next is, in a chemical equilibrium, the rate of, which one? In a chemical equilibrium, the rate constant for the backward reaction is going to be 2.5 into 10 to, backward reaction is 7.5 into 10 to the power of minus 4, and the equilibrium constant is going to be 1.5. So therefore, what is the rate constant for the what reaction? Forward reaction. We know that Kc is equal to Kf by Kb, or the rate constant for forward is Kf is equal to Kc into Kb. What is Kc here? Equilibrium constant is 1.5 into, what is the rate constant for the backward reaction? It is 7.5 into 10 to the power of minus 4. It is 11.25 approximately, these two. 7.5 into 1.5 is nearly 11.25 into 10 to the power of minus 4. So which is the answer here? Or I can write that in the form of 1.125 into 10 to the power of minus 3. Therefore, it is the A option. Means if what is given, backward rate constant for the backward reaction is given, just we have to find out the value of rate constant for the forward reaction along with the value of what is given also, Kc is given. Okay. Next. As the temperature increases, the pH of a KOH solution, what happens? Increase in temperature increases the dissociation of what? K plus and then OH minus concentration. Means it increases the concentration of what? OH minus. As OH minus increases, means the H plus concentration goes on decreasing, the pH goes on increasing. Means as what increases here? Temperature increases, the pH of the KOH solution will start to get increased. That is the general concept. That is 16b. Okay. Next, 17. What is the H plus concentration in mole per liter of a solution? That is 0.2 molar in sodium acetate and 0.1 molar in case of what? Acetic acid. Given K for what concentration? Acetic acid is going to be 1.8 into 10 to the power of minus 5. So here, sodium acetate and acetic acid, it is an acidic buffer. What buffer it is? For acidic buffer, we know that pH is equal to pKa plus log base 10 of what by what? Salt by acid. Salt by acid. We can have directly the H plus concentration formula. H plus is equal to Ka into acid concentration divided by salt concentration. So this is the direct formula. Okay. This is called Henderson's-Hasselbalch equation, or in deriving that we are getting an intermediate equation, that is H plus is equal to K into acid concentration divided by what? Salt concentration. So here what is K value? 1.8 into 10 to the power of minus 5. What is the acid concentration? Which is the acid here? Acetic acid. Acetic acid is going to be 0.1 divided by sodium acetate is going to be what? 0.2 molar. So 1s are 2s are 0.9, or I can write that in the form of 9 into 10 to the power of minus 6. So that is 9 into 10 to the power of minus 6 is the what concentration? Hydrogen in concentration if it contains 0.2 molar of sodium acetate and 0.1 molar of what acid? Acetic acid. Okay. Next. The KSP for chromium hydroxide is that 1.6 10 to the power of 30. The molar solubility of this compound in water is how much? Here the KSP is given, just we have to find out the molar solubility. Chromium hydroxide, this is of the type AB3. If that be the case, what is KSP here? KSP is equal to 1 to the power of 1. Here M is equal to 1 and N is equal to 3. 1 to the power of 1 is 1, 3 to the power of 3 is 27. 27 into S to the power of 1 plus 3, that is equal to 4. R. We need the molar solubility. N is equal to 4th root of KSP divided by 27. KSP divided by 27. That is equal to 4th root of, what is KSP given? 1.6 into 10 to the power of 30 divided by 27. The 4th root of 1.6 into 10 to the power of 30 divided by 27, that is equal to what? C. Okay. Next, in that particular what equation? Hydrolytic equation. What is that? A minus gives rise to A minus plus H2O gives rise to HA plus what? OH minus. K for that substance is found to be 1.0 into 10 to the power of minus 5. Therefore, the degree of hydrolysis is how much? In concentration of 0.001 molar of that particular salt. Okay. What he has, we have to find out. So here, A minus plus H2O gives rise to HA plus OH minus. So this is called as anionic hydrolysis. Anionic hydrolysis means it is a salt of weak acid and a strong base. It is a salt of a what and a what? Weak acid and then the strong base. Therefore, according to that, the degree of hydrolysis is given by root of KH by C, where KH is called as degree of hydrolysis. Degree of hydrolysis. That's also equal to KH divided by C. So therefore, KH divided by C or KH divided by KH into C. K into C. Okay. So that is the simplified formula. KH by C first. KH by C is given by again KW, sorry, because as it is an ionic product of water. That is equal to root of, what is KW as usual? 10 to the power of minus 14 divided by, what is dissociation constant? A, Ka, 1 into 10 to the power of minus 5. Once the molar concentration 0.001 means it is simplified as 10 to the power of minus 3. So here it is minus 8, here it is minus 14 means minus 6. Minus 6 root means 10 to the power of minus 3. That is equal to. So that is the value of which one? Degree of hydrolysis for a salt. What is that salt here? It is A minus plus H2O gives rise to HA plus OH minus, because it is a salt of a what and a what? Weak acid and then the strong base. Okay. Next, 1.6 moles of PCl5 gas is placed in 4 dm cube closed vessel. When the temperature is raised to 500 Kelvin, it decomposes and at equilibrium 1.2 moles of PCl5 remains. What is the Kc value for the decomposition of PCl5 to PCl3 and Cl2 at that particular temperature of 500 Kelvin? So here, PCl5 gives rise to what plus what? PCl3 plus Cl2. So initially, how much has taken here? 1.6 in how much dm cube? 4 dm cube. What's the meaning of 1.6 mole per 4 dm cube? Means it is equivalent to 0.4 mole per dm cube. Means the concentration is 0.4 mole directly. Why? Instead of calculating first the number of moles and then converting it to concentration, 1.6 moles of PCl5 in 4 dm cube is nothing but, for 1 dm cube it is 0.4. 0.4 means the molar concentration is 0.4 here. Initially it is what and what? 0 and 0. When the temperature is raised to how much? 5 Kelvin, 500 Kelvin, decompose it and at equilibrium how much is present? 1.2 moles of PCl5 is present. 1.25 in how much dm cube again? 4 dm cube means its concentration is divided by 4, that is equal to 0.3 molar of which is present? PCl5. Means that is present at what equilibrium? At equilibrium. Means PCl5 left is found to be 0.3 molar. If this is 0.3 molar, here it is 0.1 molar. Or 0.1 molar. If this is 0.1, here also it is 0.1, here also it is 0.1, here it is 0.1, here it is, because left is 0.3 means how much it has reacted? Only this. Okay. Then the value of what? Equilibrium constant, I think. The Kc value for that one is PCl3 concentration into Cl2 concentration divided by PCl5 concentration. What's the PCl3 here? 0.1 into 0.1 divided by 0.3. 1s are 3s are, that is equal to 0.03. 0.03. This is the value. Means instead of calculating the number of moles, directly we are converting that into the molar concentration, because how much mole? 1.6 moles in 4 dm cube means it is 0.4 mole per how much dm cube? 1 dm cube, it is simply called as 0.4 molar. Okay. Similarly, 1.2 moles of PCl5 left means what is the concentration? 1.2 divided by 4, that is equal to how much molar? 0.4. 0.3 molar has been left means how much it gets reacted? It is 0.1. So based on that, we are getting the values of equilibrium concentrations of PCl5, PCl3 and then Cl2, and on substitution we are getting the final answer as what? 0.033. Okay. So that is about the which one? Question number 20. Okay. Let's move on to the next one. 10 to the power of minus 6 molar NaOH solution is diluted by how many times? 10 times. Therefore, the pH of that particular diluted base is how much? So first you have to be very familiar. Dilution of a neutral solution, acidic solution, dilution of solution of basic. Its value is less than 7, pH value is 7 and then pH is greater than 7. Okay, first general. The dilution of acidic solution, so here first the dilution of which one? Neutral solution. H plus same, pH remains the same, that is equal to 7. Means the dilution of exactly neutral doesn't change the value of which one? pH. Whereas dilution of what? pH, which is less than 7. Dilution increases the concentration of H plus and this decreases the pH up to pH, H plus concentration. What happens? The pH value goes on, H plus concentration goes on. H plus concentration decrease, sorry, because it is dilution. pH gets increased and attains a constant pH of what? 7. No doubt, the pH value goes on increasing. To what extent? Only up to the pH of how much? 7. Because after that 7 means the pH of a neutral solution dilution remains the same. Similarly, if this be the case, OH minus decreases, our H plus concentration goes on increasing, our pH goes on decreasing and finally attains pH is equal to exactly what? 7. No doubt it also gets decreased, but to what extent? It is up to the only the 7. Okay. 10 to the power of minus 6 molar NaOH solution implies OH minus concentration is 10 to the power of minus 6 molar. Dilution by how many times? 100 times. Means OH minus concentration is equal to what? 10 to the power of minus 6 divided by 100. Because diluted by how many times? 100 times. That is equal to 10 to the power of minus 8. Therefore, OH minus concentration is equal to 10 to the power of minus 8 plus 10 to the power of minus 7. Why? Because this is from water. This is from what? OH, NaOH. Why? Because in that we are having the water also. What water will have? H plus concentration of 10 to the power of minus 7 and OH minus concentration of again 10 to the power of minus 7. That is equal to 1.1 into 10 to the power of minus 7. If I simplify that. Okay. Therefore, what is POH? 7 minus log 1.1, that is equal to 7 minus 0 point something, that is equal to 6 point something. Therefore, this is actually the POH, sorry. Therefore, pH is what? 14 minus 6 point something, that is equal to 7 point something, means it is in between what and what? 7 and 8. 7 and 8 is the pH of which solution? NaOH solution of 10 to the power of minus 6 molar when it is diluted by how many times? 100 times. Okay. So this will have this not completing, it is, will stop at this particular stage, and we will the rest of the MCQs that we will discuss in the next session. Okay. So thank you.